Hey guys, welcome. Thanks for the invite, Andrew. Yesterday, Andrew asked if I'd be willing to give a talk here today on something, and he suggested Stucco, and I thought that's a great idea. About 45 minutes ago, I started putting a couple of slides together, and we're just gonna have at it. So I'm gonna introduce Stucco, a PowerShell module today, and talk about what it's used for, and then we can start playing with it and um, show what it produces and how it can help you build more community community aimed modules that you can work on collaboratively. So I am Joshua Hendricks, at Joshua J is my handle pretty much everywhere. And yeah, I live in Oregon, and I'm a principal engineer with Milestone Systems. Have about 20 years or so in IT, doing application support and software development, and primarily in C#, but in the last few years I've been doing a lot of PowerShell as well. I published a module back in 2019 called Milestone PS Tools, and continue to maintain that today. That's specific to the product that my company produces, video surveillance related software. And so this is a module to help configure that software, do reporting, all that fun stuff. And that was my introduction to PowerShell. I was both learning PowerShell and building this module at the same time back in 2019. So like I said, I have a background in C#, and yeah, you can find stuff online at joshuaj.com, and hit me up on Twitter/X/Mastodon, wherever. So getting to the topic, what is Stucco? So Stucco, the name, it's a play on words. So similar to, kind of like platypus is a mammal, and it produces a mammal file for your PowerShell documentation. Stucco is a plaster template that produces scaffolding for a new PowerShell module. And so there might be a bunch of new words in there for some people. And so we'll go into detail about what scaffolding is and all that. But the gist of it is that in whatever programming language you use, there's usually sort of a standard format for the source code for that project. Some number of files and folders and things just kind of usually go in a certain place, and they don't always have to go in that place, but the community is used to that project format. And so Stucco is a module that will generate the scaffolding for a PowerShell module with a structure that a lot of people in the PowerShell community are really used to, and is designed to be easy to evolve your projects over time. So it was written by Brandon Olin, who is Dev Black Ops online. He's got a book called Building PowerShell Modules, I think. It's on LeanPub, and I don't remember if he mentions this module in that book, but I think I started reading that book first and then discovered Stucco after that. And then Stucco introduced me to a bunch of new concepts for PowerShell module development. And so today, time permitting, we'll step through all of those different features that the scaffolding produces. And we're going to use a version of Stucco that was updated and republished by Jimmy Briggs called PS Stucco. So Brandon Olin is a busy guy. He has not updated the module in a couple years, and it's really, really good. But there's just a few little issues here and there, and a guy, Jimmy Briggs, republished a version of this with a number of little fixes. So we're going to use that version today. So I just pulled this straight out of the documentation on GitHub on the README. So it's an opinionated plaster template. So plaster is a module that lets you produce some scaffolding based on a template that you define in XML. And we're not going to talk a lot about plaster, but that's what Stucco is. It's a module that uses plaster to produce the scaffolding. And it's opinionated, meaning there's a lot of decisions that are made in the structure of the scaffolding that are that don't have to be that way. You don't have to use that format, but it's a useful format. You can do what I did, which is just use it, and then over time, when you realize that you want to do something differently, just change it. So some of the key features that that Stucco implements in the projects that it produces. So it has a change log with a specific formatting that's enforced by pester tests. It's got some community-focused stuff like a code of conduct, and it has documentation support using mkdocs, which lets you produce documentation using Markdown format. So you can generate a website and host it on GitHub Pages, for example. And that's it's all built into the build script that it produces. Then we have platyps support for generating Markdown-based help for your online docs. We have dependency resolution support using a module called psdepend. And so that allows you to define what your project dependencies are. So if you, in order to build the module, if you need a specific other module or some command line tool or something, you can define that in a requirements file so that when you run the build script, it'll take care of making sure that those dependencies are present. So you don't have to, have a 3-page document describing how to set up a build system. It's just all built into the repository. So for the build process, it's using a module called Saki. And so that's kind of a task runner tool where you can define discrete tasks like build and test and whatever. So we'll step through that. It has support for various different pipelines. I use GitHub Actions, but there's support for app failure pipelines, and it basically just produces a document, a YAML file specific to that platform with some default build steps. Yeah, so let's get into VS Code and actually see what this module is all about. All right, so I started up a repository here, but I'm actually going to clear it out and start over. Where can I put this window? There we go. Just going to make sure this is big enough for the recording. And I'm going to make that full screen. Alrighty, now while I was playing with this just for the call, I noticed that there is another breaking change somewhere really in PowerShell 7.4 where the build script fails because of there's a new, what do you call it, built-in parameter in PowerShell 7.4 that wasn't present in earlier versions, and that messes up one of the tests in the build script. And anyway, we're going to use Windows PowerShell for the presentation, but you should be able to use this with PowerShell 7.4. There might just need to be a couple of bug fixes in the module. All right, so we're going to do install module PS Stucco. I already have the module installed, so I don't need to do that. Then we're going to do new Stucco module. And the destination path, we're just going to do the current folder. So I'll put a little dot there. And now this is where the whole plaster template thing comes in. So the Stucco module is defining a plaster template with a bunch of questions that it uses that it'll prompt you with. And then based on your answers, that'll change the output. So we'll just say demo module. And then it's going to ask for an initial version number. I usually just kind of enter through these. So the default here in parentheses is 0.1.0. That's good enough for me. And it's getting my name from my Git configuration in Windows. So it already knows that. And I'll go with an MIT license. Sounds good to me. Now it's asking if I want to include a code of conduct. This is specific to GitHub and I mean any platform really, but on GitHub, if you define a code of conduct, that kind of gives you your module or your repository just a little bit more community support and lets people know what your expectations are and all that. It's not really necessary for something that maybe you just use on your own or maybe a couple of people use, but for a module where you're accepting pull requests, things like that, it's a good idea to have. And so if you ask for a code of conduct to be included, it'll ask for an email address to include in that code of conduct. And now it's asking if we want mkdocs support. Yes, we do, definitely. And it's going to ask for a site name. You can always change this later, it doesn't matter. And then it's asking for a Git repository URL. I don't have one. This isn't a module that is, I don't have a repository on GitHub already, but it's not going to let you proceed without something in there. So I'm going to give it something. There we go. And now it's asking if we'll be using PowerShell classes. And I'm going to say yes. And then later I'll show you what it does as a result of saying yes here. Will we be using PlatEPS for help documentation? Yes, please. Do we want VS Code dev container support? Absolutely. And now it's asking what platform do we want to use for CI/CD or continuous integration, continuous deployment? So if you're not familiar with pipelines or CI/CD, the idea is you have a file that describes your whatever steps are necessary to build or test or publish the module or publish documentation. You can define those in your repository, and there's different platforms like AppFair, Azure DevOps, GitHub Actions, all kinds of platforms for CI/CD. But most of the community tends to use GitHub Actions, or I've seen a number of people using AppFair as well. We're going to go with GitHub Actions. And now it's scaffolding. So we just got a whole bunch of text in here telling us what it's doing. And if we open up our file explorer, we're going to see a whole bunch of new stuff. So let's step through this. The entry point, the idea with this scaffolding is that your entry point to build your module is this build.ps1. So anytime you want to, you update the module and you want to build a new version of it, then you would just run build.ps1 and then debug the error messages that you got. Whoops. ./build.ps1. And I didn't specify a task, so it's just going to do the default stuff. And it got pretty far. Let's go through some of this output. So this module depends on a module called build helpers that generates some environment variables that can then be used during the build script, and they come in handy for a lot of automation. And then we have these tasks. So it's doing a clean, which is probably just clearing whatever the contents are in this output folder. Stage files, And so when it's doing a stage, it's taking your module, which is defined in a folder in your repository that is named after the module. So we have a folder called demo module. I probably should have not put a space in the name, but that's fine. And so this is where our source code lives. Here's one of our functions, get hello world. And then any private functions that our public functions might need, we'd put in the private folder. And if we use PowerShell classes, then those would be defined in the classes folder. And one of the reasons it's useful to have your functions in their own files like that is that it becomes easier to find things. So instead of having everything in your PSM1 file and getting to hundreds or thousands of lines in here in your source code repository, each function is neatly stored in its own file and easy to find. You can hit Control P in VS Code, for example, and do get dash hello world and jump right to it. Another reason is if you do collaborate with other people, you might be working on this get hello world function and somebody else might be working on another function. And if they're in the same file, then you're both trying to edit the same file at the same time and then commit your changes and share your changes with everybody else. And once one person makes a change, then everybody else needs to pull down that change before they can merge their own changes into it. And you end up with these collisions and it becomes kind of a pain. So by having things in their own files, there's a lot less chance that you're going to have a merge conflict like that. So if we look at the PSM1, our module file, it's super basic. So out of the box, it's getting a list of classes, because each class, you'll have some number of class files, which are just PS1 files that define the class. You'll have some number of public functions and private functions, and then it's going through that whole list of files and dot sourcing them, which means effectively we're grabbing that file path for your public function, and then it's essentially like copying and pasting it into the current script so that they become available after that line. Any functions defined in there become available. And one of the rules, again, this is an opinionated structure for a PowerShell module. One of the rules is that your public functions, the file name, get-hello world.ps1, the file name should match the function name. And the reason is that down here, when the module exports, it basically says, here's the public functions that are available, it's going to take all of those file names that it found and grab the base name, which is everything before the dot, and say, here's all my function names that I have available. And by doing that, this module file becomes super simple and small. You can extend it later if you need to with, you might have some script scope variables. Maybe you load in a configuration from a file or something like that, and then that variable is shared with your public or private functions. You might define those in your PSM1, but otherwise you try to keep your functions in their own files. And so when we do a build, we're taking the contents of this and really we're just copying it over to the output folder. So if we look at the path here, we have an output folder, and then we have the name of our module, and then we have the version, and that was based on our manifest file. So if we look at the PSD one, it says module version 010. So that's a structure that it produced, and then this would be your build artifact, and that's kind of a term that if you're familiar with software development in other languages like C# or Java or something, when you compile an application in another language, you take your source code and then squeeze it through some process that compiles it into some kind of executable or artifact. So this is our build artifact and what we would publish to the PowerShell gallery, or zip up and attach to a release on GitHub or something like that. All right, so there's a lot more to step through in this scaffolding. There's a bunch of files here. Does anybody have any questions or confusion that I can clear up, or something I should talk about first?
Not
If
from
not,
here.
I think I'm pretty good.
all right. Feel free to interrupt me. I can't see the chat, but if anybody has any questions or want me to elaborate on anything, just feel free to jump in. I think I might, just to be organized, just kind of quickly go down from the top to bottom and briefly describe each section. And then we can dive deeper if anybody wants to go there. All right, so it created a .dev container folder. And if you haven't heard of dev containers before, I highly recommend diving into it. It's super cool. So one of the biggest advantages of a dev container is that if you have a project that you're working on with multiple people, you can make sure that everybody has an identical development environment. So if we look at our dev container.json, this is describing our dev container. And so it says there's a Docker file that describes the container that we want to start from. And then it has some information about our VS Code settings that we want in that dev container environment. And then it's got a post create command that just says, once this container is created, please run this task. So it's running PowerShell and doing a build with just doing an initialization. So it's not actually going to build the module. It's just going to prepare the environment. And this bootstrap parameter, we'll pull up the build script here. So the build script has a bootstrap parameter, a bootstrap switch. And if you specify -bootstrap, it's going to look in your requirements.psd1. And this is that ps depend module that's going to look at this file. And it's going to make sure that you have the ps depend version 038. It's going to make sure that you have pester version 5.40. And if you don't, it's going to install it for you. And so there's a number of modules described here that are required for the build process. And so that dev container, because of that -bootstrap, dev container is going to have all of these modules ready to go every time you run it. There we go. And then we have this Docker file that is based on the PowerShell container. And looks like it's pretty basic. It's just making sure that it's updated, that it has Git and an OpenSSH client for remote access. It's creating a user, a VS Code user, so that you can, because ideally, you generally want to avoid being root in any environment unless you need to. So it's creating that user. Otherwise, it's not really doing much else. And then, yeah, if you run this as a dev container, you can run it locally if you have Docker or Podman or something installed. Scratch that. Podman is not supported. It does need Docker, but if you have Docker desktop or you install Docker in a WSL instance manually, then it'll be able to use that. So you can run your container locally and it feels like you're developing on your local machine, but you're really developing in a container. and then you also, by having that dev container in your project, if you log into GitHub, you'll be able to see that you or any collaborators can launch a code space, which is just a dev container, but running on GitHub's cloud, so that you can do development in in an environment in VS Code within a browser, or you can connect from your local Visual Studio to your code space on GitHub, and you don't even have to have Docker or anything installed locally. So dev containers, super fun. I like those. Then we have our .github folder, and this is specific to if you're using GitHub as for your source control, but it's got a default template for when people create issues, so you can customize it from there, and instructions for how to contribute to the module. And then most importantly, it has workflows, which are your GitHub actions. So this file describes what to do when somebody pushes a change to your main branch on GitHub. And so it'll run through some tests. And it looks like that's all it's doing by default. So you can see down here that it's running that build.ps1 again. So again, that build.ps1 is your entry point, whether you're doing a build or a test locally, or you're testing or building or publishing on in your pipeline on GitHub or wherever. Ideally, everything goes through build.ps1, and just try to keep it simple. And with that dash bootstrap, that just makes sure that your build machine that's running on GitHub has all the dependencies it needs before it actually runs the tests.
Hey, Josh, I have a question.
Yeah, go for it.
Hey, this is from Edgar. Does PS Stucco only provide a template to build modules? What about scripts with a requirement for a specific module? Does it accommodate for that?
It is specifically for templating out a new module. So what you could do is take the script that you have and create a new module template. And then if you go into your module folder in here, you can break up your script into individual functions and then turn your script into a module that is more portable and easier to share with other people, and parameterized, so that, depending on what your module or what your script is doing, there might be some environment specific parameters that, instead of having them built into the script, you could parameterize those in your functions, so that other people could take advantage of those without having to modify the script. Hopefully that answers the
Awesome.
question.
I think it does. And I think that PS depend is also sort of the thing he might be looking at as well. If you're
Okay.
just interested in dependencies, potentially, but I think he might have a follow-up question. Go ahead.
yeah, so this is Edgar. So I just wanted to follow up since, eventually I understand what you're saying with, trying to break up the script into multiple, functions to be more portable.
Mhm.
But eventually, this has to be run. Let's say it's a controller script.
Sure.
So I'm assuming this doesn't accommodate that. You'd have to do that yourself and make its own requirements and all of that.
Yeah, your controller script would need to make sure that the dependencies are there, or maybe the module that is used by your controller script has some of the dependencies built in, or takes care of resolving those for you. So yeah, you could potentially even use the PS depend module, or something similar to trigger the installation of dependencies when the module is loaded, potentially. Yeah, it just kind of depends. But
Okay. I only
yeah.
inquired because I know there's like commandlets to publish scripts up to a NuGet repository. So, and it does attach with requirements of a module. So, if you
Okay.
publish the script up there and it already has the module it depends on, when you download the script or when you do install PS resource or something like that for that
Mhm.
script, it'll download the module with it.
Okay. I admit because I started using PowerShell in 2019, the concept of modules already existed, and I've never looked into publishing scripts to PS Gallery. I know that I've come across scripts that are published there, but my feeling was that that was how things used to be done, and then more commonly today we would take those scripts and turn them into modules and publish those. And in your module manifest, which is that PSD1 file here, you would specify if you have a dependency on another module. Scroll down, there it is. So we would uncomment this required modules section and say, hey, this module needs, I don't know, import Excel. And now if you turned your script into a module and then you installed the module, this would get installed at the same time if you install it with install-module.
Right, I can see the dependency chain. I'm just wondering, at some point, you need a controller script if you're going to do some sort of automation. And it would be, I'm just thinking like that would be best if the controller script can just depend on the module that it requires to run those functions.
Yeah, I would probably be building in to that controller script, like at the top of it, taking care of the dependencies. Because obviously you could, maybe your script depends on PS depend to install some dependencies, but then you have to install PS depend before you can use it. And where is it? You've got to, so it has to start somewhere in the build script here, and maybe you could use this as a reference. It says if bootstrap is present, then this is where it starts. It checks to see, make sure that the NuGet package provider is installed, make sure that PS Gallery is available, and then it looks at that requirements.psd1, and then if PS depend isn't available, it installs it, and then it's going to go ahead and import PS depend, and then it invokes PS depend pointing to that requirements file. And then that's where any of those other dependencies, in this case, like Saki and build helpers and platyps, everything defined in that requirements.psd1 get installed. So maybe your script defines a hash table. Does PS depend support passing in requirements as a hash table? It might not. But in any case, you might have a hash table that is at the top of your script with your requirements defined, and then use PS depend to install those. There's a lot of different ways to do it. You could also take a look at Module Fast by Justin Grody, and consider using that if it makes sense. I think that will help you install a lot of different types of dependencies really fast. So yeah, lots of different ways to do it. Cool. All right. Feel free to interrupt at any point if you have some questions, want to dive into anything deeper. There's also a .vs Code folder here that just describes some basic environment settings. So we're going to use the one true brace strategy or syntax, and that just makes sure that your curly braces are on the same line, your opening curly braces on the same line as the if and all that fun stuff. There's a lot, people can argue about what the right formatting is. The right formatting ultimately is whatever everybody agrees to use if you're working on a project with multiple people. So, and then we have some built-in tasks that in VS Code, a task is for like build or debug. There's different tasks you might perform, and so you can define what happens when you want to do a test versus a build, and that just makes it so that your keyboard shortcuts, or if I do Control-Shift-P and I do build, when I do that run build task, it's just going to do that. And then everybody can use the same build task and accomplish the same thing. This also, you can declare extensions that you'd recommend people to have when they're doing development. And then if they're not using a dev container, then that'll just suggest to them, hey, you might want to install this extension, make your experience better. All right, and then we have this demo module folder. It's there because we called our module demo module. And so in this structure, whatever folder your source code is in, you would have a subfolder named after the module, and that's where your source code would live. In a lot of other, if you look at a C# project, that might be src source. In this case, it's just the name of the module. Then we have a docs folder. So here's our markdown for our functions. So as we write new functions, PlattyPS is going to automatically build a markdown version of your documentation. And then that markdown documentation, it renders really nicely in GitHub. But if you use mkdocs and publish a website based on your markdown docs, it's going to turn out and look really good. I'll show you a quick example here. So the Milestone PS Tools project has quite a lot of commands. If we look at get VMS camera, for example, there's our PowerShell documentation all rendered from Markdown into a nice website. And it is super searchable too. So that's the power of mkdocs, specifically combined with the material for mkdocs theme. I have a whole session that was like 3 hours that if you have a spare 3 hours to watch a YouTube video on docs, you're welcome to do that. But anyway, that docs folder is automatically generated for you as you update your commands or add new commands. And then we have our output. So again, that's whenever we do a build, it's going to copy our module into the output folder. Then we have some built-in tests. So it's going to make sure that your help files are actually filled out. Because when you generate documentation for a function that doesn't have any comment-based help, then it's going to put placeholders everywhere. And this is going to make sure that you don't publish your documentation with placeholders. That'll throw an error and prevent your tests from passing. And this is going to do some tests on your module manifest to make sure that like the version that you declare in your manifest matches the version that is in your change log at the top of your change log, and a bunch of other things. I forget. I think this is checking for like tabs versus spaces and making sure things are consistent. You're not using UTF-8 or excuse me, yeah, like mixed encoding or mixed new line types. And yeah, we already covered the build.ps1. Here's the change log. And so the idea is you can follow the link here and it'll tell you, what that sort of changelog format, recommended changelog format is. In this case, it expects that whatever the version is in the top section matches the manifest file, your module manifest. And then when you publish a new version, then you would put in the publish date here. And then you would start a new version. And just over time, as you make changes, you might say added your new function, and just kind of helps people stay on top of what changes you've been making. Then we have our code of conduct. Here's that mkdocs file, and again, it's super basic. That repo URL that we put in when we ran the new Stucco module, that's right there. If I publish this to GitHub and suddenly have a actual repo URL, then I would just update that here. The effect of that is that in your website, if you publish it, at the top right, you'll see a link by default that says go to repository, and you can see the number of stars and forks and all that fun stuff. So by providing that repo URL there, it'll make sure that it has a link to it, and then you can define what theme you want. Again, there's lots of documentation out there on MKDocs and the different themes. So definitely recommend taking a look if you're interested in doing docs. And yeah, I think the last file here is this Saki file. Now the PowerShell, one of the dependencies of this module project based on the scaffold is that it uses PowerShell build. PowerShell build has default build tasks for PowerShell modules, both in that are compatible with Saki and also with invoke build. So Saki and invoke build are like two competing tools for running tasks in your build process. Invoke build has been around a lot longer and has probably more support in like hardcore developer environments that are also doing PowerShell stuff. Whereas Saki is a little bit newer and might be a little bit more familiar for people that are maybe new to PowerShell. I'm not sure. This is the only one I've used. So, and the idea is that Saki has this task function, and you can define whatever tasks you want. They can be named anything you want. In this case, it's saying the default task. If you don't say what task you want to run, it's going to depend on test, which means if you don't specify any task, it's going to run the test task. And the test task depends on some other tasks. So I'll open up the terminal again. Okay, so the test task depends on clean, stage files, generate markdown, depends on a bunch of different things. And so by updating our Saki file, we can have the build process do additional things if we need to. And that'll just evolve over time as you build your module. Like with one of my projects, one of the things that I do is it's a hybrid. It uses both a compiled C# DLL and PowerShell script functions. And so I have build tasks for actually building the C# project and then copying those into the output when I build the module. And so they just kind of evolve organically over time. If we look at the PowerShell build docs, can't remember which organization that's under. It's probably under Brandon Olin as well. Nope, it's under the Saki org. So PowerShell build has a lot of its own options. So one of the things that I took advantage of is the compile feature. So again, PowerShell, not a compiled language, but if you have a lot of functions, let's take a look at our output. We only have one function, but if we look at our output, we basically have the same structure as our source. So it just was a straight copy. And if we have a lot of individual files in our module, it can be faster to compile the module by taking all of the contents of those functions and putting them in the PSM1 at build time. So your source code is still individual files, but when you build the module and test it, or when you publish the module, that version has everything in your PSM1. So by adding that option here, we can now do another build. Really wish that error wasn't there, but oh well. Then we take a look at our output, and now we have a PSD1 and a PSM1, and that's it. So we can see that it took the contents of the class file, our private functions, our public functions. It took everything and dropped it into that PSM1 so that there aren't any other files that it has to load. So again, most modules probably not necessary, but that's kind of a nice touch for larger modules and can speed up that import time. So that is kind of, we touched briefly on pretty much every component of the scaffolding that's produced by Stucco. So I think that's kind of the end of my presentation, and we're on to if you guys have any questions or other topics, anything that brought to mind, happy to answer any questions you got.
I'll give some initial thoughts. So basically, if you're creating a module, there's a lot to it, potentially. You could have it simple, PSM1, PSD1. But if you're actually looking to create tools that are shareable, a little bit more maintainable, get added features like a lot of the stuff you showed, you can use something like Sake. And Stucco. I will also say that you showed off a lot of the things that it produces are really impactful and powerful, even if you don't adopt Stucco. Just the .vs code folder that you showed, if you can at least standardize around how you expect things to be formatted and common modules, if you can get that .vs code folder going around, that alone is a huge win from what I've seen. Yeah, the settings are fantastic. Extensions, auto-suggest stuff, tasks is really powerful. And you can learn from the way that it is automatically generated here. You can just take that, customize it a little bit, make it fit your needs. But the jumping off point that you're provided with something like this is pretty huge.
Yeah, definitely. If you've heard of the term linting, this is almost like linting, where you define a structure, like a set of standards for your source code. You know, like your braces start on a new line versus on the same line, and that by following those standards, everything looks congruent. When multiple people contribute to the same project, you try to follow the same standards, and it just helps to make everything look neat. And this will help encourage people to follow those standards. Yeah, and when I started learning PowerShell, like I said, at the same time that I was building a C# based module, and so I made lots of mistakes and started with a very simple project that wasn't even in version control to begin with, and I slowly adopted new ways of working on the project over time. But the big jump was when I discovered the Sake module and or not Sake, the Stucco module, and all of the different components that it implements in that development process, in that build process. So then I took the module that I was working on and sort of just jammed it into this structure, and that became my new repository after that. So, and I just dug into each little piece over time as it made sense. If you start
Awesome.
your module off, even without using Stucco, if you try to adopt this structure, and there's a blog post, a really great blog post by Rambling Cookie Monster on this public-private folder structure for your modules. Just doing that alone makes a big difference with the development experience. It's a really great structure to start from.
Is it possible for you to expand on that a little bit more?
Yeah. So the this public-private, classes structure, it's a nice template for structuring your source code for your module, as well as the publish module. and it's used by a lot of people in the PowerShell community. So if you look at other, common modules, you'll run into this pattern quite a lot, where our PSD1, our manifest, let's go to the top here. It says this is the start of the module. The root of the module is that demo module.psm1, and then PowerShell will load this file and go and discover your source files, your functions, your classes, whatever you're using, and then dot source them all into the module. And by doing that, it keeps your code a little cleaner, a little bit more organized, and especially when you're working on a module with multiple people, it makes collaboration a lot easier. So when you make a change somewhere and then you commit those changes and push it up to GitHub, there's less risk of two people modifying the same file at the same time, and then you having to deal with a merge conflict where you decide who wins and what the change looks like after you merge them all together. So but again, when you're just getting started building a PowerShell module, all you need is that PSM one, and you can put all your functions in here, and that's a perfectly fine place to start. And in a lot of cases, that might be all you need, depending on how widely shared the module is. If it's just you or it's just an internal module that is used within your company or something, that's good enough. And then as it grows, then it might make sense to get a structure that's easier to work on with multiple people.
Thank you.
Yeah, no worries.
I will say that while you're right, and I definitely recommend just getting whatever you can do done, whatever works, there is so much fun and room to grow once you start dabbling into a lot of the stuff that you showed here today. And it can open you up to a whole bunch of cool new opportunities and jobs and conversations and opportunities to contribute to other projects. Because a lot of the public PowerShell projects out there have a similar flow of folders. And I know for me, whenever I look at a new project, I am pretty much, well, before I kind of went through it and learned it all, instantly overwhelmed. A million folders, a million files, all kinds of stuff that I have no clue about. But you can decode that, a lot more stuff starts being possible for you. So awesome. Well, thank you so much to Josh Hendricks for teaching us all about Stucco, install module, or install PS resource, PS Stucco maybe. Get yourself started.
Yeah, thanks, man.
Awesome.
Happy to be here, and yeah, thanks a lot, guys.
Well, I will go ahead and stop the recording. Those of us who are virtual, I'll be here chatting for a few minutes. I know that people in the library are probably getting a message any minute now from the librarians telling you that you need to get out. But thanks everybody for joining us.